Hi and welcome to this on Maths prediction for the AQA Maths GCSE Higher Tier November 2020 Paper 1. Enjoy! Hi and welcome to this on Maths prediction for the Maths GCSE November 2020 series. So this is a really strange year, as I'm sure you're aware, that we haven't had a GCSE paper in the summer. This paper will be the first GCSE paper almost all of you will have sat, with the exception being Year 13 students who are resitting the Maths GCSE. So it's really, really important that you are prepared, both in your knowledge of the subject and just to your knowledge about how the exam works. And this is what this prediction is supposed to be used for. Please don't 100% rely on this prediction. First of all, the accuracy has been good in the past, but it's never 100%. There's always topics that are not predicted that come up in the actual paper. So make sure you do your revision. What some students do is they do this test now, see how far they can go with it, go off and revise, and then do the test later on to see whether they've improved their marks. And the way they can do that is, you can do it too, is if you go to onmaths.com, you can try this paper online for free. The numbers change each time, so you're not just remembering answers, you actually have to work them out. And it will give you a grade as you go along on the paper, just like this video. So you'll see exactly what grade you are at each point of the paper. We've got loads and loads of other stuff on the website. I'm not going to go into it, but there's loads and loads of stuff that you can also do. And if you click up here, which I think is there, it will take you straight through to the correct paper, so you can just get started straight away. If you want to sit back and just watch how to do the questions, feel free. If you want to give that a go first and then come back to this video, there's a link to this video in the actual GCSE paper on our site. Without further ado, I should say everything is completely free. You are not charged for anything on onmaths.com. So, let's get started. When numbers are quite small, it's quite easy just to do trial and error to find the highest common factor and the lowest common multiple. But when the numbers are larger, then the way we do it is with product of prime factors. Now, this could come up on a paper which has previously had product of prime factors, and this is distinct enough maybe to come up in its own right. So just because product of prime factors have already appeared, this question has already done that bit for you. So how are we going to do it with these large numbers? And 3,675 and 84 are pretty large numbers. Well, the way we do this is with a Venn diagram. Now, I'm going to use the space down here to do this. And what I'm going to do is, because I find it easier, I'm just going to write it not in index form. And then when I do my Venn diagram, I can just cross them out when I've done them. So 2 times 2 times 3 times 7. Okay, so let's construct myself a Venn diagram. Okay. Now, I'm not very good at drawing circles, but I'm going to try my best here. I'm going to try and make the circles as big as possible. So we've got 3,675. I'm just labelling which circle is which, and this is 84. And to do the Venn diagram, we're just going to go through the numbers and write out which ones overlap and which ones don't. So if I have a look at the 84 first, we've got a 2 there. Well, 2 doesn't go into 3,675, so that 2 is going to be on its own there, and this 2 here is going to be on its own. Okay, I think that's it. So the next one, now this 3 appears in both lists, so this 3 goes in the middle. The 5 here only appears in 3,675, and same with this one. And then we've got 1 7 that appears in both lists, but we've got another 7 in the 3,675 list. So that's my completed Venn diagram. Now, to answer question A, to find the highest common factor, all you need to do is multiply the overlapping ones together. So the highest common factor is 21, and that's it. Here we are, it's that easy. Now, to find the lowest common multiple, which is question B, what you need to do is times all of them together, every single one. And you might wonder, well, hang on, surely that's just going to give us 3,675 times 84, so why couldn't I just do that? Well, the overlapping ones we're only going to write once. So the 3 and the 7 in the middle, we're only writing them once. So we would, if we did 3,675 times 84, we would be timesing by 3 and then timesing by 7 again. So we've already done the middle bit. So we've already done the 21 in the middle. And I need to do the ones around the side. So we've got 5 times 5 times 7 times 2 times 2. Now on the non-calculator paper, it might be a bit more generous with the numbers. This one is probably going to be more on the calculator paper, although there are ways that you can do this. For instance, I could pair the 5s and the 2s up, and that would make 10. The 5 and the 2 there would make another 10, so we've got 100. So all we need to do is 21 times 7 and then put 2 zeros on the end of it. 21 times 7 is 147, so put 2 zeros at the end of it. If it's on the calculator paper, you just literally use your calculator to times them out. And so that's 14,700. Well, the chances of us finding that with trial and error are close to impossible, so you can see why this method is so good. Okay, so this is quite a complicated question because there's two ratios and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated, but the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4-3, and rugby to tennis is 6-13. So these two ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here, which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the two together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle round, we've got the rugby as 3 parts of that, but in the green one the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8 to 6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these two up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18. And 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. So it's not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier. Okay, so first of all, we're asked to find that to prove that they are congruent. Now, congruent means exactly the same lengths, exactly the same angles, exactly the same shape, so exactly the same thing, but you can rotate with congruency. Okay, so the proofs are side, side, side. Well, we only have 2 of the sides. Now, theoretically, we could work out the other side by using Pythagoras' theorem, but we don't actually have to do that. So you could use side, side, side by using Pythagoras, working out the third side, and then working from there. The other one is AAS or ASA, which is angles, angle, side, angle. Now, we're only given one angle, which is the 90 degrees, so we're not going to be using that one. The other one is side, angle, side. Well, we have a side and an angle and another side, but the problem is the angle needs to be between the sides, and here the 90 degrees isn't between those two sides, so it's not going to be that one. The last one is RHS, right angle, hypotenuse, side. So let's have a look and see if we've got that one. Well, we've got the right angle, we've got the hypotenuse, and then we've got another side. All three of those, obviously the right angle is the same, but all three of those are the same. So the right angle is there, the hypotenuse is 12 meters, and then the other side is 7 meters. So the proof that we use for this is just RHS. Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top, and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls, so in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15, and the mean number of coins for the boys is 13, and we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. And try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys, so let's work out how many the boys have. So same triangle. We know the mean for the boys is 13, and we know that there are 12 boys. So we'll do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300, take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, the easiest way of doing this question is to do yourself a quick number line. Now we put the number we're given in the middle, 24. Try and think what the next number down would have been. Well, it's to the nearest kilogram, so it's going to be 23. The next number up would have been 25. Now, the maximum weight it could have been is going to be halfway between what it was and the next one up. So the next one up is 25, so halfway between those two is 24.5. So the maximum it could have been is 24.5. Now note here, I know that 24.5 would have technically rounded to 25, and some of you might be tempted to write this as an answer. Now you'd get the mark if you wrote that as the answer, however, that is the same, exactly the same as 24.5. It's one of those weird things in maths that 24.49 recurring is the same as 24.5. And this one here is a heck of a lot easier to work with, especially if there's a further part to this question. So you will always get the mark for writing down 24.5. The only exception to that is if something's not continuous. And if it's just whole number. So if you're counting, if you're doing the number of people to the nearest 10 and it was 30, then you'd have to write down 34 as the maximum, because 35 would have rounded up to 40. But mostly it's going to be continuous, so mostly you can just write 24.5. Okay, so for the first thing to do with this question is to write it out twice. Whenever you square something, you times it by itself, and itself is the bracket x minus 15. And there are multiple ways of doing the next bit. I'm going to use the grid method for this one. And we put the first bracket at the top, so x minus 15, and the other bracket down the side, which is just x minus 15 as well. And we're timesing, so x times x is x squared, x times minus 15 is minus 15x, x times minus 15 is minus 15x, and then minus 15 times minus 15 is plus 225. Okay, then these two here will add together, so when we write our answer it's x squared minus 30x plus 225. Now the really common answer to this is people thinking it's x squared plus 225. Okay, and that is wrong. Okay, students do that, and I'll put a big cross through it. Students do that because they don't understand that you're squaring the whole bracket, you're not just squaring the things inside the bracket. Okay, so we're given a graph in this question, and it says use the graph to work out if A and B are in direct proportion. Now there's a few rules for direct proportion. The main rule is it needs to go through the origin, so it needs to start the bottom left. And the second rule is it needs to be a straight line. So the one I've just drawn now is in direct proportion, but here you can see that it doesn't start at the origin, and if it did start at the origin it wouldn't be able to go down. It is a straight line though, but because it doesn't start at the origin, it doesn't go through 0, 0, you can say A and B are not in direct proportion. Okay, so we're asked to translate the shape by this vector and label it B. So for vectors, we always write down how far right at the top and how far up at the bottom. So we've got 2 right, but here it says minus 4, so that means we're going down 4. To do a translation, always start off picking a point on the shape, and I always pick up the top left one, but it doesn't matter as long as we're consistent with the later steps. And I'm going to follow this instruction, so it says 2 right, so let's actually just show that with arrows, it'll probably be easier. So 2 right, and it will be 4 down, because it's always positive if it's up and negative if it's down. So 2 right and 4 down. So I'm going to jump 1, 2 to the right, 1, 2, 3, 4 down. Now I'm going to then draw in shape B. Now be really careful. That point here on shape A shows that the point I'm moving is the top left of that shape. So when I'm drawing it in, I need to go 2 down from there, and then I'm going to go 4 across. So I'm just copying in that original shape, and let's join these up. Now if you're not sure, you can just pick the another point, and we're going to go 2 right from the bottom right of the shape, and 4 down, 1, 2, 3, 4, and it joins up perfectly. We can do that with the last one, 1, 2, 1, 2, 3, 4, and it joins up perfectly. And this is shape B. So you can just move one point and then draw the shape in, or you can move all the points and just join them up, and that's absolutely valid. Just make sure that you start and end on the same point on both the shapes, because often students might draw in the shape like that, even though they originally picked the top left one. So that would be not very good, because that won't get the full marks. Okay, so this question looks a little bit complicated, in fact very complicated, but whenever you have this type of question where you've got different categories of people or items, the best method and the clearest method is to draw a quick two-way table, which I'm going to do now. So I'm going to draw a quick two-way table, and the options for the people are either they are male or they are female. We'll add a total column or a total row, and they either do maths, English, science, and again I'll add a total as well. Okay, so I can add some lines in as well. In fact, let's do a different colour to make it a bit clearer. Okay, the absolute total is 123. Okay, and we just go through and fill in the bits we do know. So 57 of the students are female, so 57 females. 15 of the 36 students who went to English were male, so there's 36 students who went to English, and 15 of them were male. 33 students went to science, and 29 males went to maths. So 29 males went to maths. Okay, what we asked for, so we're looking for the females who went to science. So if I highlight that, so females who went to science. So we're looking for this one here. Okay, so what you can do with this question is just try and fill out the bits that you can, right? So I'm going to start off with this top one here. Okay, and there's different ways of doing this. Now, if there's 123 students in total and 57 of them are female, then 66 of them will be male. Okay, because these two here have to add up to 123. Then if there's 66 males in total and 29 of them went to maths and 15 of them went to English, then that leaves 22 who went to science. And if there's 22 males who went to science and there's 33 people in total who went to science, then there's going to be 11 females who went to science. Now there's different ways of doing this question, and actually you didn't need to do a two-way table for this question. It's just a lot easier to check your answer, and I find it a lot quicker. So if you have this type of question, a two-way table is probably the way to go. Okay, there are two things you need to know, main things you need to know about kind of advanced number indices. And the first one is that anything to the power of 0 is not 0, but it is 1. And the reason being is, say we had 10 squared divided by 10 squared, that would be, take away the powers, so that would be 10 to the power of 0, because when you divide you take away the powers. But any number divided by itself is 1. So therefore anything to the power of 0 is 1. The second thing you need to remember is if you have a negative power, all you do is you get the number, it's 3 to the power of 1, which is just 3, and put a 1 over it. So if you had 2 to the power of minus 2, that would be 1 over 2 squared, or a quarter. So the negative just results in putting a 1 over it. Now if you have a fraction, and we do it to the power of a negative, you actually just flip the fraction. And that's it. That's called finding reciprocal. So there we go. If you ask to find the reciprocal of something, you just put a 1 over it if it's an integer, if it's a whole number, or just flip it if it's a fraction. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. So this question says that y is inversely proportional to x. So the way of writing that down is you do y fish, and fish isn't its actual name, but it looks like a fish, and that means y is proportional. The inversely bit means we put 1 over x, and that's the difference. So if it says inversely, you put 1 over it. Now we're going to get rid of that fish sign, so we're going to put an equals in. But to do that, I need to times the right hand side by k, so it becomes k over x. Now we're given a value of y and a value of x, so we're going to use that to work out what k is, and it's k for constant, even though constant starts with a c. So k won't change, so once we find it once, it's going to stay that way. Okay, so y is 7 when x is 9.1. So I'm going to draw my lines in. I'm going to times both sides by 9.1. So 7 times 9.1 on the calculator, and I get 63.7 equals k, or k equals 63.7. So I'm going to go back to this equation here, and y and x will keep changing, but k won't. So y equals 63.7 over x, and that is our equation. Okay, so we've got a right angled triangle for this question, and we've got 2 lengths and an angle, so it's going to be a trigonometry question, but it's going to be on the non-calculator most likely, so we need to try and find a way of finishing it off. But I'm going to start it as I would do normally. I'm going to go to the right angle, go opposite that, and that's your hypotenuse. I'm going to go to the marked angle, opposite that is the opposite, and the one left over is the adjacent, and that's the one between the right angle and the marked angle. And then go cross out the one we're not using. Well, A is 1 centimetre, O is X, so H isn't useful to us. Going to write out SO, CA, TOA, which obviously you need to know off by heart, which are the 3 triangles, trigonometric ratios. Now we're going to cross out the ones with H in because we're not using H, so we're left with TOA. Now TOA stands for tan the angle, which is 60 in this question, equaling opposite, which is x, over the adjacent, which is 1. And because we don't have a calculator, we can't then finish off this question without using the method I've described in an earlier video, so I'll leave a link in the description, where you just write out the numbers 0, 30, 45, 60 and 90. And the idea here is to work out the exact values of tan 30, tan 45, tan 60, is you circle the one you're trying to find. Well, here we're looking for tan 60, and you put the numbers on the left as a square root over the numbers on the right as a square root. So with this, it's going to be square root 3, because there's 3 numbers on the left, over square root 1. Which just equals root 3 over 1. So, to find out the value of x, well, if tan 60 is the same as root 3 over 1, and we've got the adjacent as 1, then x needs to be root 3. Alright, so we're not given very much to go on in this question. This p means find the probability of. This one here says A and B. Now, the way I remember it is I just put a line through this and it's and. Now, the word and means you have to have A and B. You can't just have A or just have B. So the one we're looking for is this one here. So the probability is going to be 7 over, and we need the total, so all of them added together. So that's going to be 7 over 23. Let's check that. 7 plus 3 is 10, plus 10 is 20, plus 3 is 23. So our answer is 7 over 23. Okay, in order to this question, we need to be familiar with the formula y equals mx plus c. Now, the m in this is the gradient, and the c, or the plus c, is the y-intercept. Now, the first thing we need to find out is the gradient, so we're going to work out m first. Now, to do the gradient, the formula is change in y over change in x. So if you have a look, we start off at 5 for the x and minus 10 for the y, and then we go to 13 for the x and minus 42 for the y. So to work out the change in y, we do the final y, which is minus 42, and we take away the initial y, which is minus 10. We do the same with the x's, so 13 take away 5, and find out how much it's changed. So those two minuses make a plus, so it's minus 42 plus 10, which is minus 32, over, and then we're going to do 13 take away 5, which is 8. Okay, so minus 32 divided by 8 is going to be minus 4. So the gradient is minus 4. So we know that it's going to be y equals minus 4x plus something. So we could need to work out what the y-intercept is. And the way of doing that is we just put in the two values here, we could have picked the other ones, into y equals mx plus c. So we're going to find out what c is by substituting in those values. So it's going to be minus 10 equals, and then we've worked out the gradient, which is minus 4, times the x, which is 5, plus c. Now c is the one we're trying to find, so we're going to leave that as a c. Okay, so minus 10 equals minus 4 times 5 is minus 20, plus c, and we're going to add 20 to both sides. So that's going to be 10 equals c, or c equals 10. I mean, same thing. Okay, so we've worked out what c is, so we can actually write the formula now, or the equation of the line now. So it's minus 4x plus 10, which is plus 10 because c is positive. If c was negative, it would be take away the value. Okay, so we asked Hannah's invested some money in the bank, and she uses a formula to work out how much money she's given after a certain amount of years. So the 2,200 here is the amount of money that she had. The n here is the number of years, and the m is the amount in her account. So the only thing that really hasn't been discussed is this number here. This number here is a multiplier. So to find a multiplier, you start off with 100%, you add on the percentage increase, and then you divide by 100. So we're just going to do the other way. So we're going to start off with the multiplier. We're going to times it by 100 to get the percentage. So it's 101.1%. And then what we're going to do is just take away 100%, because that's the initial amount, and see what we've done to it. Well, we've increased it by 1.1%. So that shows a 1.1% increase. So the first thing we're going to do is fill out the table. And so when it's x cubed plus 10, I'm just going to cube the x and then add 10. So 0 cubed plus 10 is just 10. And I always start off with 0 because it's normally the easiest. Then I go for the positive numbers. So 1 cubed is 1, plus 10 is 11. 2 cubed, so 2 times 2 times 2 is 8, plus 10 is 18. And 3 cubed, 3 times 3 is 9, times 3 is 27, so that's going to be 37. Now minus 1 cubed. Now some people think that minus 1 cubed will be a positive number, but it's minus 1 times minus 1, which is 1, times minus 1, which actually is going to be minus 1. So it's minus 1 plus 10, which is going to be 9. And then minus 2 cubed is going to be minus 8 plus 10, which is going to be 2. So when we plot this on the graph, minus 2 is going to be at 2, minus 1 is at 9, 0, 10, 1 is 11, 2 is 18, and 3 is 37. Okay, and you want to try and join these up with a curve. It looks like an S, the cubic, like that. Sometimes you get a dip like that. On this one you don't. So let's try and join these up with one straight line. I've already broken that rule. Oh, it's not very easy on this. And I would say that that's good enough. There's a little bit of wiggle there, but I think I can get away with that. The important thing is it goes through all the points and it's just one straight line. You don't do any feathering, and feathering is where you go like this. You know, I've exaggerated it slightly, but you just want to draw one line. Okay, so it says use a graph to find out the value of x when y is 15. So what I'm going to do is I'm going to draw a line across where y is 15. So y is 15 here. And the solution is going to be where the two lines hit. Now I think that's 1.7, so I'm going to go for 1.7 because it asks for one decimal place. Now normally with drawing questions, because people draw slightly different, normally there's a little bit of leeway in it, as long as you've used your graph and you've shown the examiner that you've used that line there. Okay, so we're asked to rearrange this formula, and I'm just going to write it out again so that I've got a bit of space to work in. Now we want to make W the subject, which means we want to get W equals and then whatever it equals. So the first thing I'm going to do, well, we could times all three terms by 7, but students often forget to times all three terms by 7. So we're going to focus on the 91. We're going to take away 91 from both sides. That leaves us with a minus 91 on the left hand side, and then this fraction on the right hand side. Now we want to get rid of that fraction, so to do that we're going to times both sides by 7. Now I could write 7a minus whatever 91 times 7 is, or I could just leave it in a bracket, and that's absolutely fine. Now I'm just going to switch this around. In fact, I might switch this around and continue working up here, so I've got a bit more space. And I haven't actually changed anything, I've just switched the equation around the other way. So I've got the W on the left hand side. And last thing I'm going to do is divide by 4 both sides. So W, because we've got rid of that 4 by dividing it. And I can write this as a fraction. So I just leave it, all of that over 4. And that's absolutely acceptable. In fact, that's the only way we can write that, because we can't cancel the 7 and the 4. Now, if you expanded the brackets, that would be absolutely fine. You'd still get the right answer. It's just I don't really want to times 7 by 91 if I don't have to. Okay, so box plot question. Now, it might be tempting to think that the information here is all you need to plot on the box plot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other 2 that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students. So I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5. That doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down because you've shown that it's 17.5, well, you can't get half a student, so let's go for 17 or let's go for 18. Okay, so this looks like a very, very complicated question. Now, there are multiple ways of doing this, so if you do this a different way to the way I do, but you've written down all your reasons as you've gone along and you get the same answer, that's absolutely fine, and that's to be expected with more complicated questions. So the first thing I notice with this question is we have an isosceles triangle here, because they're both radii. So that's an isosceles triangle, so we know that the bottom two angles are equal. Therefore, to work them out, we do 180 degrees, angles in a triangle, take away the 40, which is 140 degrees. And then we do 140 divided by 2, because we know the two remaining angles, which are this one here and this one here, are going to be equal. So that's 70 degrees. So we know that they're 70 degrees. Okay, now, this is the interesting bit. This bit here is going to be 80 degrees, because we're just adding them together. And that is going to be equal to x. So x is going to be 80 degrees. And the reason for that is when you have a triangle, which we do here, this big one here, coming off a tangent, which is this here, then you have a weird circle theorem. It's the famous circle theorem called alternate segment theorem that states that the angle here, well, let's do a different colour, here, is equal to the angle here. It's quite a weird one because they're the opposite sides. So the left-hand side of the triangle is equal to the right-hand side from the triangle to the tangent. But the good thing about this circle theorem is you just need to write down 3 words. Alternate segment theorem. The mark scheme will always just be those 3 words, so don't try and write a different explanation. It will just have those 3 words. Now, this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x. And the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So, all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this.
And it's the same question, just written differently. And at this level, you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh, okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's close to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. And now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3.
Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down b, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of a, so I'm just going to write a squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by k, so it becomes k over a squared. Now I'm going to pick a value of a and b. Now a and b are called variables, they're going to change. The k though is a constant. When we find k once, we found k for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says b is 1/8, so I'm going to substitute in b is 1/8. And k we are trying to find out, and it says a squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what k is. So it becomes 64 over 8 equals k, so therefore k is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So b equals 8 over a squared. Okay, I'm going to use that to find out what a is when b is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of b I'm just going to write 2. So 2 equals 8 over a squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by a squared. So the best thing to do is get rid of any brackets or fractions. And since that means divide, over means divide by a squared, I'm going to times by a squared. So it would be 2a squared equals 8. Then I'm going to divide by 2 both sides. So I get the a squared in its own. So it's a squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value. So a equals 2. So if I put a as 2 into the answer to question A, it would be 8 over 2 squared, which is 4. So 8 over 4, which is 2. So b equals 2.
Now there's a couple of ways of doing this question. We're asked to complete the table and then complete the histogram. You can do this by counting squares, but I'm just going to use the formula for this. And the formula, choose the right one. The formula has frequency at the top and frequency density and class width at the bottom. And it works the same way as most, or speed, distance, time, and all of those ones. So we know that class width, let's work out the class widths for these. That's going to be 40, that's going to be 40, that's going to be 20. And I'm just looking at the distances between the 80 and the 100, so I'm doing 100 take away 80. So the next one's going to be 40, and the last one is going to be 60. Okay, now I know that I do the frequency divided by the class width to work out the frequency density. So I'm going to do 44 divided by 40. So I'm going to divide that by the class width, which gives me 1.1. Now if I go to my diagram and label that as 1.1, because frequency density is on that axis, on the y-axis, then if I look down, well, I notice that that's going to be 1.0, 0.8, 0.6, 0.4, 0.2 and 0. So it works perfectly, and then obviously 1.2 at the top. So now I know my frequency densities, I can actually work out what the next frequencies are. So the next one has a frequency density of 0.6. So I'm going to times that by 0.6, because this is our frequency densities. Times that by 0.6, so I'm going to do 40 times 0.6, which is 24. The next one has a frequency density of 1.2, looking at the graph, or looking at the histogram, so 1.2. So I do 20 times 1.2, which is 24 as well. Okay, this time I've got to work backwards. So I've given the frequency and I've given the class width. So I need to divide them across. So divide that by 40 and divide that by 60 to work out the frequency densities. So 24 divided by 40 is going to be 0.6, and 36 divided by 60 is going to be 0.6 as well. Well, that's convenient. So they're both 0.6. So the first bar is going to be at 100 to 140, and it's going to be 0.6. So 140 is going to be there. And then the next bar is going to be 140 to 200. So it's a slightly longer bar there. And I'm just putting these off center so you can see them a little bit better. Now you don't need to shade these bars in, just draw them with a pencil and a ruler, and then that's it. Okay, so we're given a quadratic here to solve. So first of all we need to factorize it, since this probably is on the non-calculated question, so we can't use the quadratic formula. Okay, so the first thing I'm going to do is find the product of these two numbers. So I'm going to do 12 times 6, which is 72. So I need two numbers that multiply together to make 72 and add together to make minus 17. So let's have a think. 4 times 18 6 times 12, 8 times 9, 8 and 9. So we've got to make minus 17, so it's got to be minus 8 and minus 9. Okay, next thing I need to do is just write out the question as before, but instead of minus 17x, I'm going to write minus 8x minus 9x, and then plus 6 like the question. Now that's equal to 0, so I need to put that in. Okay, now what I'm going to do is just focus on these two, and then I'm just going to focus on these two. So just focusing on the first green box, I want to factorize this so I can get a 4 out and I can divide an x out. So that will make 3x minus 2. Okay, now I have to bring the negative out because I don't want a negative here. So negative, and it's going to be 3. So that will leave 3x, and then I'm dividing the negative out. So this needs to be negative as well, so negative 2. And then if you expand that, it's minus 3 times minus 2, which is positive 6. Then I'm going to take the two numbers outside the bracket and make a bracket with them. So 4x minus 3. And I'm also going to remember to put the equal 0, because I keep forgetting that. And then I'm going to just write the repeated bracket once. There we go. Okay, in order for these two brackets to equal 0, one of them's got to be 0. So if we go through each one, so I'm going to say, start off with 4x minus 3 equals 0. I'm going to add 3 to both sides. Then I'm going to divide by 4. So it's 3/4. So our first answer is 3/4. Then I'm going to do the same with the 3x minus 2. I'm going to do it up here. 3x minus 2 equals 0. Add 2 both sides. And then divide by 3. So that gives us the second answer, which is 2/3. Now we can try and substitute that in if we've got time. They're not the easiest things to substitute in fractions, but if you substituted either of those into the left hand side, you would get 0.
First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences, we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on an uncalculated paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, alright, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we've got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together.
Okay, so we've got a recurring decimal, but we have an annoying 0 there. So what I'm going to do is I'm going to answer the question, convert this into a fraction, and I'm just going to worry about that 0 later on. So we're going to call x 0.9898 recurring, and so therefore 100x would be 98.9898 recurring. So 99x, by taking away these two, would be 98, and then these will cancel. And then let's put my lines in. So divide both sides by 99. You get x equals 98 over 99. Now we know to get from 0.98 recurring to 0.098 recurring, we're going to divide by 10. So we need to divide our fraction by 10. And you should know that the rules are same change flip or KFC or whatever you want to do. So you can convert that to a times by flipping the fraction. And so 98 times 1 at the top is 98. And 99 times 10 at the bottom is 990. Now there's something else I can do. I can cancel this down. So I can halve top and bottom, so 495 at the bottom and half of that is going to be 49. Now 49 has 1, 49 and 7 as factors, and I don't believe 7 goes into 495. For the cancelling of this, they're not normally that devious, and it will either be dividing top and bottom by 10 or dividing top and bottom by 2, but just be prepared. Okay, to answer this question you need to understand the sine wave, and the sine wave starts at 0 and then goes up to 1 at 90, goes back to 0 at 180, down to -1 at 270, and then back up to 0 at 360. Now what's happening here is we're taking away 30 before we put it into sine. So at this point here, sine thinks we're at 0 because that point there is 30. So we're going to do 30 take away 30, which is 0. Sine thinks we're at 0, which it will spit out the 0 as the answer. Similarly, at this point here, it's 120. We're going to take away 30, which is 90, so sine thinks we're at 90. So all the way along here, sine thinks that we're kind of 30 to the left. And so it will be very similar to a sine wave, but it will just have moved to the right. I'm rubbish at drawing these. That was really poor because that went up too quickly there. And this is kind of a stretched out one. So we're going to go up to here, then we're going to go back down to here. Now notice that it doesn't start at 0, it starts somewhere, and I've estimated here, somewhere there, and it doesn't end at 0, because it will go back to 0 at 390, because then we'll do 390 take away 30, which is 360, so it doesn't end at 0. So the rule is that if you minus something within a function, then it moves right by that amount, and it's counterintuitive. You'd think if you take away 30 it will move left 30, but it goes the other way, and hopefully I've explained why. When you're asked to solve equations graphically, this time we've got a linear one and a circular equation, all you need to do is draw them out onto the graph and write down the coordinates where they intersect. So looking at this one, the two lines intersect here and here. So for the first one, x equals 0 and y equals -3. And for the second one I circled, x equals 3 and y equals 0. This question might just ask you to rationalise the denominator. It might ask this question in the form that it's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, a positive times a negative is a negative, and any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those. So that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website, on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's been caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.